This video is entitled RoboWOKI Indirection. Indirection, I'm James Renaud, PhD from Shawnee State University, and I'll be taking you through this kind of thought idea here. Indirection in computer science is where we give something a name that references something else. Sometimes it's a value that we give a name, that we call those variables. We can give a name to a constant, set something over in the memory and say that doesn't change, let's give it a name. That way we don't have to remember the value, but we just remember the name of the value. Again, a variable is like a variable in mathematics where the variable can change its value, but the value has a name. It kind of represents a place in the computer's memory where we can change things. Indirection can also be used to reference a block of computer code. We can create a block of computer code or a block of sequence and say, well, that sequence has a name. We're going to name that sequence something and use it again and again. So that's another form of indirection. RoboWOKI is such a simplistic language. It doesn't have variables. It doesn't let you add and subtract. It doesn't do much of it much. It's basically just telling this little robot where to go. But it does offer indirection that allows us to create new commands. Right now we know the 4 commands of forward, back, right, and left, and we know how to do a star for iteration. But indirection will let us create new letters or new commands to be able to tell the robot little shortcuts. So let's look at the existing program that we did in the last video. So here's the world, and the world basically says go 4 F, turn right, and then go 4 more F. Star 4 F, R, star 4 F. Well, that's interesting. What if I'm going to change that code? Oops. I'm going to change that code to say plus X, F, 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 dot, and then I'm going to go XRX. Let's go XRX. So let's take a look at what that code does. Now it looks a little crazy, it looks a little complex. Once you get the ideas down, it's not going to be that crazy. The plus sign tells RoboWOKI we're going to create this sequence and we're going to give it a name. And you're going to use that sequence as if it were a single statement. So let's look here. The sequence is the first letter after the plus is the new name of the sequence. Now, you can't use a number. You can't use one of the symbols that RoboWOKI uses. You can't use the letters B, C, R, L, F or P, but you can use any other letter of the alphabet. So I'm using the letter X to represent this. I could use the letter Q, I could use the letter Z, I could use the letter A. I could name my sequence, my indirection, anything I want. Here in this example, I'm using the letter X. So I say plus X, so that says, let's start a new sequence. And the sequence follows, followed by the period. The sequence ends followed by the period. So the definition for X ends when it finds the period. So there are 4 F's. So now there's a new RoboWOKI statement, a new RoboWOKI command called X. And X says move forward 4. X says F, 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 F. So the XRX at the end says, okay, now that we've defined our new indirection, let's the sequence, the next thing we do is start executing them. So X would jump back into the indirection, execute the sequence of 4 F's, then it comes back to R, and then it jumps back over to the indirection, executes the 4 F's, and the program ends. Let's watch it work. Run code. And you can see how it did just exactly what we wanted it to do. And if you followed the little words down here at the bottom, let me slow that down so that we can watch it. If you notice at operation 7, then operation 2, 3, 4, 5, 8 and then 2, 3, 4, 5. So you can watch it there in the message box and actually see what character you're on in your sequence. You can actually kind of follow what it's doing and watch it jump from the X over into the indirection X, execute the Fs out of X. You know, we could make that a little prettier by saying, you know what, why don't we do an iteration in the indirection? Well, that's good, or F. So now I've changed it to X, create the indirection X. The indirection is star 4F. So that means there'll be an iteration inside the indirection. If your brain's not starting to bubble, I think this is really a lot of fun, and I hope you're enjoying telling the robot where to go. So you can see now that our indirection includes an iteration, and if we run the program, it works just exactly like we told it. Works exactly like we told it to do before. Yeah. So with indirections, there's one more crazy thing that indirections. Well, first thing, once the robot finds the last coin, the program ends. Even if there's still statements in the sequence left, the robot comes to a stop when we find the last coin. Why am I saying that? Well, that's just one of the definitions in RoboWOKI, but it also kind of creates a neat idea because I can add an R to the indirection and change the program to this. So let's look at what I just changed the program to. I said plus X star 4FR dot. So I've created the indirection X that has the loop of 4Fs and an R. So it's going to, the first time we call X, it's going to go all the way across and turn right. And then the second time we X, it's going to go down 4, find the coin, and the program stops. And that last R doesn't get executed, does it? Just doesn't do it. So I can change the end of the program, the sequence at the end, to XX. Execute X twice, and Bob's your uncle. It should work like a charm. So let's run that and see. Oh, I slowed it down a little too slow. Let's speed it up a little bit so that it's, you see you can adjust the speed. So you can see that worked just exactly the same and did it in 9 moves. There's one more crazy concept that I want to introduce here. And it's really an advanced concept in computer science. It's probably beyond what we're going to do in most of this class, but it's still something I need you to at least be able to describe and kind of think about for a moment. And that is the concept of recursion. Ooh, sometimes my brain just forgets things. So that's the idea of recursion. So I've just changed the program here. Let's take a look at the program now. I've changed the program to plus X star F star 4F RX. So let's see, the definition X does 4 Fs, then an R, and then calls the definition X. Wait a minute. It calls itself, doesn't it? So what's going to happen now is that when we execute X, X will repeat forever. X will repeat forever. Take a look at the code. Pay attention to the code here because you can see that plus X star 4FR X says, okay, after you go forward 4, after you turn right, then go back and do X again. So it does X a second time. And if the program hadn't ended, it would go back and do it a third time and a fourth time. And then at the end of the sequence, you see I just have a single X to say, start it off and loop forever until you find all the coins. So the program will terminate as soon as the little robot gets to the last coin. But we can run the code and see that in fact the robot does exactly what we wanted it to do by calling X the second time, and then it terminates because it found the last coin. So we've talked about sequence, we've talked about iteration, we've talked about indirection, and we've talked about this crazy computer sciencey thing called recursion in these first three videos. I hope you're having fun with these problems, and I hope you're having fun getting to know the little robot. And I hope that these videos are helping seal these concepts into your head. I'd like to say thank you for watching. This video is copyright 2021 by James Imrano, PhD. You can contact me at shawnee.edu or jrenault at shawnee.edu. And again, thank you for watching, and I'll see you in the next one.